So I have shared a link for recorded videos. I think you can access those videos, right? Can you access the recorded videos? I have shared a link. Are you aware of it?
Yes, sir.
Yeah, okay. Okay, so do you remember what we were talking about last time? So what we were talking about in the previous session? Okay, so
about equivalence class.
yes, and we tried to understand various equivalence classes for particular relation, right? So we saw this relation on R2. R2 means plane. 2 points are related. If the sum of square of components are equal, then 2 points are related. And classes are circles. And how many circles? So as many points on positive x-axis, because corresponding to every point you can generate a circle. Corresponding to every point on positive x-axis there is a circle. So in this way the points on positive x-axis are sufficient to get all the circles, right? That means this circle is identified with one point, and what is the point? It intersects with x-axis. That is what the folding, as I told last time. So this is a kind of folding equivalence relations. Okay, so we'll uh, generalize this idea to some very special set, right? So that is congruence relation. Congruence relation and modular arithmetic. So what do you mean by modular or congruence? So that we'll see. Okay, so you know what is this set? What is this set?
Set of integers.
Right,
Set
so
of integers.
set of integers. So define a relation. A relation this on set of integers by for okay, a b in z is related to b if, okay, let n belongs to z. Okay, let me make it special n initially, and then we'll generalize this. So okay, so a related to b if b minus a is divisible by 5. So this is my relation. So do you understand what relation I am defining? So that is AB belongs to Z is related to B if 5 divides difference of A and B. That is, this is the definition of this relation I am defining now. So, for example, right? For example, uh, 7 and 2, are they related?
Yes, sir.
Yes.
Yes,
Right.
sir.
Because
Yes, sir.
7 minus 2 is divisible by 5. Now you can think about 17 and 2. Are they related?
Yes,
Yes,
sir.
Because
yes, sir.
17 minus 2 is 50, and which is divisible by 5. Right. Now 28 and for example 28 and 5, are they related?
No, sir.
No, sir.
No,
No,
because
sir.
28 minus 5, their difference is 23 and
23.
right, not divisible by 5. So this is what relation I am defining. So before going further, let me make some our job easy. So I will make some notations. So notations. If a and b are integers, okay, not a and b, what I should use, m and n are integers. Suppose m and n are integers. If m divides n, then what is the meaning of m divides n? What is the meaning of m divides n? See, for example, 2 divides 6. What does it mean? 6
2
is
is a factor of 6.
is right. 2 is a factor of 6. That means 6 is 2 times 3. So when I say m divides n, that means m is a factor of n. Right. That means n is equal to m times some k. Right, for some integer k. So when I say m divides n, that means m is a factor of n. Right. That means n is equal to m times k for some integer k. This is clear.
Yes, sir.
Right.
Yes.
So if m divides n, we write it as m divides n. Vertical line, not slanting line, or not backslash, or not slanting line. So this is vertical, clearly vertical line. M divides n. So what is the meaning of this? M divides n. Right. So that is same as, that is, m divides n implies n is equal to m times k for some integer k. So this is what the meaning. This is a notation, and this is a vertical line, m divides n. And remember that this is not like m by n. This is not like m by n. Remember. So m means m divides n, and m by n is something different. This is different, and this is different. So these two are not equal. So remember this. The difference you should understand, m divides n, and henceforth when I say that m divides n, that means m vertical line n, so m divides n. So this is just notation. So a is related to b if 5 divides b minus a. What does it mean? That is 5 divides b minus a. This is a notation. Is it clear? Notation is clear?
Yes, sir.
Sir.
Right.
Yes, sir.
Now I will ask you question ki, is it true or false? Or false? Is this true?
Yes, sir.
Yes,
Right.
sir,
What?
because
It is true, sir. True,
Right.
n
sir.
equal to 2 times of 5.
2 divides 10. Right. What does it mean? 2 divides 10. Now, is it true?
No, sir.
No, sir.
No, sir.
No, sir.
Is it true?
No, sir. No, sir.
No, sir.
No, sir. No, sir.
10 does not divide 2. So now idea is clear what I mean to say. We are
Yes,
just
sir.
giving notation for A divides B or M divides N. So that's it. So thus what, now go back to our relation. What is our relation? So thus for A, B belongs to integers, A related to B if 5 divides B minus A. This is our relation. Right. So now the definition of relation is clear. Definition of relation is clear.
Yes, sir.
Yes, sir.
Yes, sir.
Very good. Now, first, is it reflexive? Is this relation reflexive? Is this relation reflexive?
Yes.
So, for any integer, what is a minus a? 0.
0.
And 5 divides 0. In fact, every non-zero integer divide 0. Right? So, every non-zero integer divides 0. And therefore, 5 divides 0. So, this is true. That is 5 divides 0. 5 divides 0. This is clear. What is the conclusion? Therefore, for any a belongs to z, 5 divides a minus a. That means
The relation is
The
reflexive.
relation is reflexive.
so a related to a for all integers. That means every element is related to itself. Is to itself. And hence, this is true for every. You choose any element of Z, this is going to happen. So therefore, the relation is reflexive. Fine. Now let us check whether it is symmetric. So is it symmetric? Symmetric.
No.
Suppose A and B are integers such that A is related to B, right? Then,
Sir, can you speak louder?
so uh, A is related to B. Suppose A is related to B. Then by definition of relation, what happens? By definition of relation, what will happen?
Yes, B.
5 divides
5 divides
Ah,
7 is
then 5 divides b minus a. That means b minus a is equal to 5 times some k, right? Some integer k. Am I right?
Yes, sir.
Sir. Yes, sir.
That means so k is some integer. So there is another factor, and therefore what is minus of a minus b is equal to 5k, right? That means a minus b is equal to 5 times minus k, right? Am I right?
Yes,
What does
sir.
it what does it mean?
Yes.
So what does it mean? 5
5
divides
divides minus 2.
a minus b, because a minus b is 5 times some integer, and you can understand minus k is also integer, doesn't matter what is it, right? Uh, so when some number divides another number, there are two integers as a factors, so no matter what it is, positive or negative. So uh, 2 divides 10 and minus 2 also divides 10, correct? Because 10 is equal to minus 2 times 5, correct? Do you agree with this?
Yes.
Sir.
So what is the conclusion? What is the conclusion? If 5 divides b minus a, then 5 divides a minus b.
B is
What is my
related.
relation? So b is related to a. So thus, whenever a related to b, we have b is also related to a. Whenever, hence, this relation is symmetric. Right, so relation is symmetric. Now, transitivity. So is this relation transitive? Suppose a, b, c are integers such that a is related to b and b is related to c. What we want to check?
A
Whether,
related to C. If A is related to C. Related to C or not.
right, this is we want to check. Now, what is our assumption? A related to b and b is related to c. Therefore, by definition, what should be my next step? I am assuming that a is related to b and b related to
5
c.
divides A minus
Therefore,
B.
5 divides b minus a and 5 divides c minus b.
C
Right.
minus B.
Very good. So 5 divides c minus b. But when I say 5 divides b minus a, that means b minus a has 5 as a factor. So 5 is a factor of b minus a. So it is 5 times some k1. And c minus b is 5 times some another factor, or some k1 and k2 factors. Is it correct?
Yes, sir.
Right.
Yes, sir.
Now, what is the situation? B minus a is 5 times some integer, and c minus b is also 5 times some another integer. May not be same. Very good. So, and now if I add, because LHS is equal to RHS, if you add LHS, so b minus a plus c minus b, add left hand sides. Now, can we add right hand sides?
Yes, sir.
And then
5k1 plus
5
5.
into K1.
Plus k2.
k2, right? Which is now minus b plus b get cancelled. What remains? C minus
C
a.
minus A.
And here 5 times
K1 plus
K1
K2.
plus K2.
k2. But after all, k1 plus k2 is some integer k. What is k? K is k1 plus
Integer.
k2, and ultimately this is integer. So therefore, c minus a is multiple of 5. That means 5 is a factor of c minus a. Therefore, 5 divides c minus a. That means a related to c.
C.
And so what is the conclusion? Hence,
A is related to B and B is related to C. Therefore, A is related to C.
a related to b and b related to c imply that a related to c.
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 Therefore, is transitive. Relation is
Transitive.
so relation is transitive, and hence therefore relation is reflexive. Thus, is the relation tilde is reflexive, symmetric,
Symmetric and transitive.
Yes.
Therefore, it is equivalence relation.
right?
Equivalence relation.
Therefore, is an equivalence relation. Fine. So this relation is an equivalence relation. Now, the next job is what are equivalence classes? Now, next we want to find equivalence classes. So we want to find out equivalence classes. Okay, we'll do one by one, right? So for example, we start with 0. For example, in first step we'll try to investigate class of 0. But by definition, what is a class of 0? Right? What is a class of 0?
A comma B belongs to Z such that
So those elements, those integers, right? Because I want to find out those integers which are related to 0,
C.
right? Those integers which are related to 0. But what does it mean? Those integers which are related to 0 means their difference such
It's
that 5 divides x minus 0 or 0 minus x, because relation is symmetric, so doesn't matter x minus y or y minus x, right? That means we want to investigate those integers which for which 5 divides x, right? That means we want to investigate those integers for which x is equal to 5 times, right? So 5 divides x means what? X is multiple of 5, right? So is it clear?
Yes.
Yes,
yes.
sir.
And therefore, now can you tell me in simple words what is my set? Those integers which are multiples of 5, that means 5 times k, just vary k,
0, 5, 10.
0, 5, 10, 15, 20.
right? So what are the elements here? 0, 5, 10, 15, so on. Of course,
So it
negative
can
axis,
also be negative also.
yes, negative are also there. For example, what are the negative which are multiple of
-5, -10.
Minus
minus?
5, minus 10.
Right, so these are also there. Right, so we have set of integers, and out of those multiples of 5 are separated out, which is a class of 0. Now we'll try to investigate class of 1, because 1 is not in this class of 0. 1 is not in the class of 0, right? So as we discussed earlier, we just choose one element and look at its class, separate out. Then from the remaining, choose one element and separate out its class. So now I have chosen 1 as a representative, and I am trying to investigate class of 1. So those integers which are related with 1, correct? That means those integers for which 5 divides x minus 1. Am I right?
Yes, sir.
Yes, sir.
Right. So those integers for which x minus 1 is 5 times k, multiple of 5. Right. So just very straightforward procedure. Go step by step. And so you can clearly see the class. X is equal to 1 plus 5k. And simply what is this set? 1 plus
1.
5k, k belongs to z, just vary k, you will get all the elements which are related to 1. And therefore, can you tell me precise elements?
1, comma 6, comma 11,
And
comma
Just
6.
Yes.
right, just vary k. K is equal to 0, I will get 1. K is equal to 1, I will get 6, 11, 16, and so on.
minus
What are
4, minus 9,
minus
21.
4, minus 4, then
minus 9,
minus 9, very good. So you just investigate. Now k is equal to minus 1, what I will get? Minus 4. K is equal to minus 2 because k varies over integers. So you will get all possible. So this is a class of 1. And you can observe what are the elements in class of 1. 1, then just walk 5 steps, you will reach to 6. Just walk 5 steps, you will reach to 11. Just walk 5 more steps. From 1 you go back to 5 steps, you will reach to minus 4. Then go back 5 more steps, you will reach to, so just walk 5 steps, right? This is a class of 1. And now, so class of 0, class of 1, how many elements are exhausted now? Multiples of 5, and multiples of 5 plus 1 are exhausted. Now what are the remaining? From remaining, is 2 belongs to 0, class of 0 and class of 1? Is 2 belongs to this? No. So now just pick up 0, 2 now and look at, because from remaining you have to choose 1 and then separate out its class. So what is a class? All those integers which are related to 2. And therefore I will write in short. So 5 divides x minus 2. Correct? So what is it? All those integers which are of the type x minus 2 is equal to 5k for integers k. That means all those integers, let's say that x is equal to 2 plus 5k and k belongs to integers. And so simply what is this set? 2 plus
2,
7.
12, 17.
2, 7, 12, 17.
Minus 3.
right,
Minus 3.
Minus 8. Minus 8.
2, 7, 12, 17, and so on. And from negative side,
Minus 3.
Minus 3. Minus 8.
Minus 8.
minus 3, minus 8, just go 5 steps back, right, and so on. This will be the class of 2. Now choose one remaining element. So next, I will choose simple so that it will be easy, right? So 3 is not covered in these 3 classes, right? So 0 bar, 1 bar, and 2 bar. So 3 is not occurred in any one of these 3 classes. So I can choose now 3 as a representative. And then what is the class of 3? All those x Such that 5 divides x minus
minus 7.
3, right? And therefore it is what? 3 plus 5k. K belongs to Z. I can say 3 minus 5k doesn't matter because we are varying k over integer, so k can be negative, positive, all possible. So 3 minus 5k or 3 plus 5k, same thing, right? And so what are the members? 3
3, 8, 13, and in minus 2, minus 7, and minus 3.
Minus 3.
and from negative side minus 2,
Minus
right?
7,
Minus
minus 12.
7.
And so on. Now which element is uncovered so far? 4.
4.
So we'll choose 4 from the remaining and we'll try to investigate class of 4. So 5 divides x minus 4, right? And therefore it is simply 4 plus 5k or 4 minus 5k. K belongs to Z. And what are the members?
4,
4,
9,
9,
14,
19. 4,
14.
9,
minus
14,
1,
19, 12,
minus 1,
12,
minus
minus
6.
1, minus 6, minus
11
11.
and so on. This negative side. Okay. Now you tell me, is there any element remaining which is not covered by these 5 classes?
No, sir.
No, sir.
No,
All
sir.
integers are exhausted now.
Yes, sir.
Yes,
Yes, sir.
yes, sir.
Now observe that 0 bar union, 1 bar union, 2 bar union, 3 bar union, 4 bar union. So this is equal to all integers. No integer is now left, right? So covered. And therefore, how many classes we can produce? How many
5.
distinct?
5.
5. Therefore,
5 classes.
the equivalence classes.
Why not 5 equivalence class?
Okay. Where is 5? 5 is already in the class of 0.
Yeah, okay.
Therefore, class of 0 and class of 5 is same. Therefore, they represent same class. Right? So if you try to find out class of 5, if you try to find out class of 5, then we'll get the same class which is class of 0. You just try
Yes.
this. If
Yes.
you try to find class of 6, you will get the same as class of 1. You just check this. Right? So note that, or let me note that class of 5 bar is same as 0 bar. You just try to do the same exercise. You try to investigate class of 5, you will get the same as class of 0. Class of 6 bar is just class of 1 and so on. You check this.
So we
So
can use different relations also, no, for different equivalence classes.
I am just talking about this particular relation. Don't think about any other. So what is my relation? Two integers are related if their difference is divisible by 5. Correct?
Yes, sir.
So you can think about other relations also, but right now don't worry about such things. So just concentrate on this because this is very important part. If you understand this relation, then you can understand many things. Anyway, so there are 5 distinct equivalence classes. There are 5 distinct equivalence classes, and which are this? 0 bar, 1 bar, 2 bar.
2 bar, 3 bar, 4.
Right, because class of 5 is same as 0, so 5 is already present in the class of 0. Now you choose any integer, it is in one of them. You give me any integer, for example 2020 is in which class?
0.
5 class.
0.
0 class of 0.
0.
Right, so you just close your eyes and pick up any integer, it is in one of these 5 classes. And therefore these are the only classes. These classes will cover whole integers. right? So thus the set of equivalence classes of Z with respect to this relation tilde is denoted by, do you remember what is the notation we used?
A modulo R.
Modulo.
Z modulo tilde, because here our relation is tilde, right? But
Yes, sir.
so what is the special about this relation, right? What is the special about this relation? 5 is a special, right? And how these classes are distinguished? The classes are distinguished modulo 5. Modulo 5 means modulo multiple of 5. You see the definition 4 bar. 4 plus multiple of 5, right? 3 plus multiple of 5, 2 plus multiple of 5, 1 plus multiple of 5, 0 plus multiple of 5. So what is the special? So special is about 5. So it is multiple of 5. So modulo multiple of 5. How do we get the classes? Modulo multiple. Z modulo multiple of 5. Right. And what is this set? 0 bar, 1 bar, 2 bar, 3 bar, 4 bar. So what is Z modulo 5Z? Z modulo 5Z. So multiple of 5. This is a notation, remember. Don't bother about how I can write this. So this is a notation due to some reason, because I am identifying the classes modulo multiples of 5 modulo with respect to, right? So with respect to multiples of 5. So if it is multiple of 5 plus 0, it is in class of 0. If it is multiple of 5 plus 1, then it is in class of 1. If it is multiple of 5 plus 2, it is in class of 2, and so on. Is it clear? So this is clear. This is just notation. Is it clear?
Yes, sir.
Right.
Yes, sir.
Yes.
So this set is denoted by a special notation. Z5. What is Z5? Z modulo 5. Z modulo 5 means Z modulo 5Z, multiples of 5. So Z suffix 5. What is the meaning of Z suffix 5? Z modulo 5Z, or Z modulo this relation. So classes with respect to this equivalence relation. So 0 bar, 1 bar, 2 bar, 3 bar, 4 bar. Now if I write this as 10 bar, 11 bar, right, 12 bar, 10, 13 bar, and 14 bar. Is it correct?
Yes, sir. Yes, sir.
Right.
Yes, sir.
Doesn't matter what is the representative. What is the representative doesn't matter, because 10 is in the class of 0. Either you call 0 as a representative or 10 as a representative. The class is same. 1 is in the class of 11, or 11 is in the class of 1. So doesn't matter which you call as a representative. So they're same. But for simplicity, we are denoting this set by 0 bar, 1 bar, 2 bar, 3 bar, 4 bar. So that is simple to see, right? Because there are 5 classes. Right. So this is a set or equivalence classes. Okay. So let me make definition or notation. So if 5 divides b minus a, right? So we write it as a is congruent to b, and read it as is congruent to B modulo 5, right? So 5 divides B minus A, then we write it as A congruent to B modulo 5, right? Is it clear? And we how to read it as A congruent to B modulo. Thus, A congruent to B modulo 5 if 5 divides B minus A. For example, 7 is congruent to 2 modulo 5. Is it true?
Yes, sir.
Right,
Yes,
because
sir.
so, and now therefore our relation, what how we define the relation, tilde is A related to B if 5 divides B minus A is equivalent to saying that A related to B if A congruent to B modulo 5. Is it correct? Is it clear now? There is no confusion.
Yes.
Right. So I am just
Yes,
using
sir.
notation, and why I am using this notation, why I am changing this congruence and all these words, because there is a reason. That is what the modular arithmetic is. Right. So A is related to B if A is congruent to B modulo 5. What does it mean? If 5 divides B minus A. That is what my relation. And therefore the relation, this relation tilde is denoted by this symbol called as congruence relation. Right, because the relation tilde is now equivalent to saying that A congruent to B modulo 5. Thus, hence, what is our relation? Hence, the relation or congruence relation here, congruence relation modulo 5 is an equivalence relation. Is an equivalence relation. Congruence relation modulo 5 is an equivalence relation. And equivalence classes are grade 5, 0 bar, 1 bar, 2 bar, 3 bar, 4 bar. So there are 4 classes. So any doubt so far? If you have any doubt, you can ask me.
So how can we say any relation is congruent or not?
No, I am talking about very particular. I am not saying any relation. What relation I am saying here? If difference of A and B is divisible by 5, then these two are related. So I am talking about very particular relation. Is it clear? I am not
Okay,
saying
sir.
any relation. Right? My relation is very special. When two numbers, two integers are related, if their difference is divisible by 5, that is my relation. I am not saying any, right? And so this relation I am calling it as a congruence relation. Congruence means what? If a difference is divisible by 5, and how do I write it? This is a symbol for congruence relation. A congruent to B modulo 5 means 5 divides A minus B or B minus A, same thing. Okay, so is there any doubt, confusion?
Sir, is it necessary that the relation should be equivalence for congruence relation?
What is my congruence relation? A is congruent to B modulo 5 if, what is my congruence relation? What is my congruence relation? Right? A related to B modulo 5 means what? A congruent to B modulo 5 if. What is my congruence relation from previous discussion?
B minus.
Right? What is my congruence relation? 5 divides
B minus
B
A.
minus.
B minus A.
and what is our previous discussion? A is related to B modulo 5 if 5 divides B minus A. Now this is my relation. Now is it equivalence relation?
Yes, sir.
That is what we checked so far. So,
Yes.
so if A related when I am relating A to B, if 5 divides B minus A or A minus B, same thing, then we already verified that this relation is reflexive, symmetric, transitive, right? So that is what we did so far, but now I am just using the different notation for that relation tilde, right? What is the point here? I am replacing tilde by A related to B by A congruent to B modulo,
Modulo 5.
right? So this is the change of notation. This is change of notation. Change of notation. I am just why I am changing the notation due to some reason, because this new notation has some significance. Because we studied a very basic theory of relations, and from that basic theory, general theory of relation, I want to go to some this special kind of things which is very useful. Right, so that's why I'm changing my notation. So A related to B, I am changing to A congruent to B modulo.
Sir, but both are equal, na?
Both are same thing. Meaning of both things is same, right? A related to B. What is the meaning of this? By my previous definition of relation, our definition of relation, what is the meaning of A related to B?
5 divides B minus A.
B minus A.
And what is the meaning of this?
5
Also
divides
5 divides B minus.
B minus.
And therefore both are the same things.
Yes.
I am just changing the notation, change of notation. Is it clear?
Yes, sir.
Yes.
Right. So
Yes.
initially I defined some relation on integers and I found that it is equivalence relation. But I am just using new notation, different notation for the same relation. I am not doing anything else. So therefore, just this tilde is replaced by congruence relation. Congruence. Is it clear?
Yes, sir.
Very good. Okay. And therefore, I found that there are 5 equivalence classes. So, I want to generalize this and I want to uh, study this in more detail. So, but before that, you do one thing. Can I change 5 by some another number?
Yes, sir.
Yes, sir.
Fine. Define a relation congruence on Z by A congruent to B by A congruent to B modulo 7. Define a relation congruence on Z by A congruent to B modulo 7. Right? Means what? If 7 divides B minus A. Is it clear now? What is
Yes,
my?
sir.
I am changing
Yes,
Yes,
sir.
sir.
now. Prove that. So this relation here modulo, this is modulo 7, right? Is an equivalence relation. Right, so what are equivalence classes? Right, so you investigate this. Now I will give you one more problem. So define relation I will use some different words now. Tilde on Z by A related to B if A congruent to B modulo 6. Because now I understand कि A congruent to B modulo 6 means what?
6 divides B minus A.
Very good. And therefore A related to B if 6 divides B minus A.
B minus.
Now prove that. Right. Previous exercise and this exercise are actually same, but I am using in different words so that you can understand this. What is the meaning of congruence? So prove that. So this relation is an equivalence relation. Right. So what are equivalence classes? Question is clear?
Yes, sir.
Yes,
Okay.
sir.
Now I want to make this idea more general. Fix some natural number, right? And n is now fixed. I have just chosen some n, 110, whatever you choose n of your choice. So I have chosen some general n, some n. When I am saying fixed n, that means I am choosing particular n, whatever it may be. So A congruent to B modulo n means, what does it mean?
N
N
divides
divides
A
B
minus
minus
N
A.
divides
Right?
B
B
minus A.
minus A. Very good. So prove that. If A is congruent to B modulo n and C congruent to B modulo n, then A plus C is congruent to B plus D modulo n, and second AC is congruent to BD modulo n. So this is just very simple. When I say A congruent to B modulo n divides B minus A, that means n is a factor of B minus A, and C congruent to D modulo n means same n is a factor of D minus C. From that you check that key n is a factor of A plus C minus B plus D and AC minus BD. So the question is clear.
Yes, sir.
Okay, so
Yes,
now
Sir.
you work out these exercises, and then next time we will see very interesting things about this special, because this is a very special relation, right? So you just
yes, sir.
work out these exercises.
Okay, sir.
I think it is 2 o'clock, so we should stop here. Any doubt, any difficulty?
Sir, instead of A minus B, we also take as A plus B or A into B.